Hello, San Francisco. How's everybody doing today? Yeah, great. So yeah, so this is a session, Easy Microservices in the cloud with Kubernetes and Istio. And a little bit about me. I'm Sandil Kumar. You can reach me at this Twitter handle at SandilKumarN. And I'm basically from southern part of India, Tamil Nadu. And currently I live in the Netherlands. I'm a software engineer at Uber. So I currently started working at Uber. And I'm passionate about open source. You can see me contributing to many open source projects. I'm very active in JavaScript, as well as on Rust communities. And I'm a team member at JHipster. Anybody here already used JHipster before? Anyone? Nobody? OK, 1, 2, great. So I'm also creating JHipster. And if you want to get enrolled in an open source project and you love Kotlin, you want to get involved in Kotlin also, you can go ahead and check out here. JHipster, which is right at the beginning stage. It's a good place to start if you want to do some open source stuff. So what we're going to do today, the agenda. First, we'll see what Kubernetes is all about. How many of you have done Kubernetes before? Few? OK, great. So it will be just a brush up, and then we'll see what Kubernetes is capable of and how it works. And then we'll go ahead and check about JHipster microservices, how JHipster helps you to generate microservices, and what are the things that is included in the application that is getting generated. Then we slowly migrate to Istio, why we need Istio. Any Istio? Already using Istio here before? Anybody? A few hands. So I'll get to know more about Istio today. And finally, with JHipster, the microservices that we generated, how we can push that into cloud with Kubernetes and Istio, and we try accessing those applications. So that's what we're going to do today. Docker. Everybody remember Docker now? Great. So yeah, Docker was really awesome when it came because it had the self-contained images, and it also increased the portability of the system, which had a lot of very good impact, and that's the main reason why, as an industry, we started migrating towards Docker. But the core problem with Docker is like, it is not a tool for you to manage the infrastructure, right? And that's a very hard problem to solve. And Docker also cannot give you a feel of deciding how and when you have to run your application. So that is the problem that Docker had in it. So to solve that, we have something called Kubernetes. So Kubernetes helps you to address those things. Kubernetes actually tried to decouple this infrastructure part of your application completely. It kind of single-handedly handles everything that you want to deal with infrastructure, as well as your application management. So what is Kubernetes? It's an open source system, of course, that helps you to automate deployments of the containerized application. It also helps you to scale your application. So you can say, like, OK, give me 2 instances of this application running. Give me 4 instances of this application running. It helps you to scale up or scale down based on the resources and the load that you have. And it also helps you to manage those applications, right? So Kubernetes gives a provision in which you can manage all those applications. You can say, like, create 2 instances of this and restart whenever it goes down, or just check what is happening inside, and if there is a problem that you perceive, just go ahead and reboot everything. So that's what Kubernetes does. So Kubernetes obviously makes it really easy and simple. You guys agree with that? Right? It really makes it easy and simple. But the problem with Kubernetes is, since it has this wide range of operations, wide range of functionalities to support, it is very difficult for Kubernetes to be very simple in its architecture itself, but it's very difficult for us to understand the entire picture of Kubernetes. How does it work? How does everything fit into the picture? That's the main problem that we have with Kubernetes. So let's see how Kubernetes work. Anybody aware how Kubernetes work? Anybody? Nobody? OK, great. Then I can tell anything. OK, so basically, Kubernetes runs on a cluster mode, and you have a high available cluster mode. So when we talk about cluster, you have a master node. That's a Kubernetes master node. And you have different worker nodes. And worker nodes, again, it's a cluster base, and worker nodes inside has kubelets. And we'll see what kubelets is all about. But we have a list of small entities that is running inside those worker nodes, which are called as kubelets. So anything that comes on that line is a Kubernetes. So as a user, consider that blue dot as a user. So as a user, you create a YAML file. So that's how you go and talk with the Kubernetes. So you create some YAML files, which is very difficult for programmers to understand, but you have to if you're writing something. And then you apply this command, Kubernetes apply -f, the file name, the YAML file that you've created. And what now will happen is kubectl actually goes and talks to the API server in the Kubernetes. And then it connects via that CLI. and then it goes and sends this file there. Once the file is received, the API server will send that information to a controller. This controller inside Kubernetes is a place where, which will actually run, or which will actually determine how to run the script that you have given. And also the API server goes and stores this information in an etcd. Etcd is nothing but a key value storage that, based on which that will be stored in a Kubernetes. So whenever you want to migrate something to a newer version or something, it basically takes that information from the etcd. And finally, once you have this done, the controller sends this information to a scheduler. The controller checks, OK, this guy is capable of running, and we should run this particular person. And it sends that information to a scheduler. And basically, scheduler has nothing but a queue inside, and it puts the information inside this queue. And scheduler will then be responsible for handling all those application start, application check, and then rebooting, and all those things. So this entire Kubernetes LAN, entire thing that you see, is called as control plane, or the brain of the Kubernetes. So this is where the entire thing happens. The entire way of determining whether you have to run this application, or what are all information that you need to have in your application will be done by this control plane. So scheduler has this information. It's in the queue. And when it's getting processed, you have this worker nodes. And Kubernetes allocates a worker node based on the resource and all those things. For example, you might specify deploy it in a particular worker node, or you can also specify, go ahead and say, like, deploy any of the available nodes. And it goes and applies that updates. So it signals the start of the deployment to the kubelet. And kubelet are actually the workhorses here that kind of does whatever you want to do for deploying this application. And of course, all those worker nodes have something called as kubeproxy. And this kubeproxy is responsible for handling networking. Of course, when you're deploying something, you have to go and connect to the particular Docker containers that are running inside. And kubeproxy is the one that helps you to achieve this thing. So this is how Kubernetes works internally at a very high level. So with that single YAML file or multiple YAML files, Kubernetes actually states the desired or running state of an application. So you can actually infer how your entire application is dispersed, what kind of databases that you use, how many replicas are there, how they are interconnected to each other. All this information you can get from the state, from this YAML files that you're giving to Kubernetes. So it kind of helps you to understand the running state of the application. So any disagreements so far? No? Great. So that's how Kubernetes works. And let's move to the next place of microservices. And then we'll try to create a microservice application with JHipster. And then we'll try to run this entire application with Kubernetes and Istio. So that's what we're going to do. So microservices, the other part, the second part. So this is one of the biggest advantages of microservices, right? It helps you to do individual development. And how many of you are doing microservices today? OK. How many of you are wanted to move towards microservices from monolith today? Yeah, few. OK, great. The main advantages of microservices, there are a huge number of advantages, but just to give a brief overview, it helps you to do individual development. And it also helps you to do individual deployment. Like, for example, you have multiple different services, and all those services can be deployed with the different versions and whatever things that you want to do. And most interesting thing for me is like the fault isolation, because in case of monolith, when you have some problems, your entire application has an impact. But when you go to microservices, you can remove that particular complete service at all, and still your application has to run. If it's not running, then you have designed your microservices wrongly. And other thing is like you can granularly scale application, you scale down applications, scale up applications, and you can do all sort of things. Is there any other advantages that you think of? There are a lot of people who are in microservices world. What's the main thing that you want to have in microservices? Decoupling, exactly. OK. Any more? Sorry? Yeah, highly decoupled, isolated components. Polyglot, yeah. So that's also one of the advantages of going towards microservices. But the main problem I perceive is, in case of monolith, which is a giant purple colored thing that you have, the problem lies inside your application. So all the things, all the connections that you make, everything, the main problem is because of something, some bad code, or some code that doesn't work as desired, lives inside your application. But on the other hand, in terms of microservices, most of the time the problem arises between your applications. There's missing network connections, or the network is highly unpredictable stuff that is between your services. You could have small isolated service that works perfectly, but when you integrate with your application, then you have problems between those two things. And it's very difficult to first understand and also test. And when you have when your number of services is scaled at like thousands of services, it's very difficult for you to understand where the problem actually is, where the bottleneck of problem actually is. And that's where Istio comes into the picture and helps you to understand those things. So let's see that. So let's go move ahead and create a microservices with JHipster. But before that, how the architecture of how JHipster generates an application, and what is the architecture of the microservices that it generated. Let's have a look. And the basic pattern that we use is like API Gateway Pattern or a BFF pattern. BFF is backend for front-end pattern. And that's like, we have used this approach because most of the companies out there trying to use this approach, and we wanted to have fair majority of it. But yeah, so there are hundreds of different patterns in which you can generate your microservices. We stick with this pattern because it's much more easier, and also it covers most of the wide range of use cases. So how does a JHipster app look like? So of course, you have a backend that is written in Java or Kotlin, and it's mainly Spring Boot based. And we also have something in Micronaut coming up. But right now, we just have Spring Boot based backend application. And on the front end, we have Angular or React. We also have an option to have Vue.js for the front end, so you can also include Vue.js. And we have a user authorization and authentication system inside. If you want, optionally, you can include that. For microservices, we have something called Zool. Anybody worked with Zool before here? Yeah, so we have Zool, which is kind of a proxying service that kind of takes the information and then proxies the information to the underlying microservices that you have. And of course, with some databases, we have extensive support for all the major databases vendor, SQL and NoSQL. So this is what we have. We package this entire thing together. It's was fast. So we package this entire thing together, and this entire giant thing is called as Microservice Gateway. So this is a gateway application. So the main difference that you have to notice here is a gateway application has user authentication and authorization stuff, and it also has a front end. So this is a single endpoint in which all your clients will face this endpoint, but you have different microservices, smaller services that run elsewhere, but this will be the entry point for the web. And when you're talking about service registry, when you're talking about microservices, service registry is essential stuff. And what you guys are using for service registry or health checker here? The microservices people. What are you using for service registry? Sorry? Istio. OK. Can use that. Sorry? I didn't get your question, sorry. It is sufficient, but it's not built for this thing. That's the basic thing. So you can use Kubernetes service abstraction to use this entire thing. Service abstraction works perfectly fine. But you cannot have the drill down debugging stuff. You cannot have this add-on services on top of it. If you have to add it, then you have to modify your application. Or you have to think before doing your application. Like, for example, you have to create an application that has those components added to it if you're using Kubernetes-based service registries. And the main thing with service registry is like when you're running multiple microservices application together, your application has to connect with each other, and it has a different network elements inside it. I mean, network IPs or network service names inside it, and it has to dynamically connect to those services. And the main thing about microservices is like it has to be isolated. So when you are talking about isolated service, then you have somewhere to register the information about the services, and that's where service registry helps you to do it. And with JHipster, you get an option to choose between JHipster registry and console. The main difference is like JHipster registry is built on top of Spring Eureka, Netflix OSS, while console is from HashiCorp. So what's the main difference here is like JHipster registry always have availability over consistency. On the other hand, console will have consistency over availability. So that's the main difference. And console is actually a polyglot in nature, so you can have any kind of languages written services over there. While JHipster registry predominantly we focus on Spring and Spring Boot based Java or Kotlin applications. So everybody clear about the availability and consistency stuff here, right? Yes? No? Yeah. OK. And of course, when you're talking about microservices, you also need some consoles. And we have JHipster console, which is based on ELK stack, that is Elasticsearch, Logstash, and Kibana. So this is how your application look like. We already seen a gateway, and your clients connect to that gateway. And we have a bunch of smaller services, which are called as microservices. And you have this console or JHipster registry as a service registry, and a console through which your admins can see how your applications is behaving. So this is how an architecture, if you're generating with JHipster, looks like. And we will generate today a store gateway and notification microservice and an invoice microservice. So this is an application that we're going to generate today. A notification service, for example, will have a MongoDB-based database, while invoice service will have a MySQL-based database, and store gateway will also have a MySQL-based database. That's what it will have. So let's go ahead and create a demo application. So you have two ways of generating an application with JHipster. One is using the command line interface, CLI tool, JHipster command, after installing JHipster application. Or you can just create this JDL file and then import this JDL file to generate an application. That's as simple as that. So this JDL file, so is it visible for everybody at the back? It's fine? The font size is OK? Great. So what we have here is a single JDL file, which has 3 applications. The first application is a store application, and this is of a type gateway. And these are some Java necessary things. And I'm also specifying no service discovery type here. The main reason why I'm specifying a no discovery service type, because I'm going to use Istio for service discovery. So that's a reason why we have this. And then I have authentication with JWT. You can choose, there are multiple different authentication types that you can choose. But for now, we'll just stick with JWT. The database is MySQL. Build tool is Maven. You can choose between Gradle and Maven. The client framework is React. So you can define all those options. There are there are 10 to 15 other options there. And if you want to configure those options, you can just go ahead and configure it. On the other hand, if you don't want to specify all the options, and you just want to go ahead with simple default options, then you can just go ahead and specify empty values for all those things. It will take the default value. So this is how an application should look like. And this is another application which is of microservices type with the base name as invoice. So this is an invoice application which uses MySQL database. You can also specify the port. On the other hand, you have this notification application, which is again a microservice. But the difference here is like it is using MongoDB as database. So that's it. So for example, you can also go So let me create a sample folder here. So let me check whether I'm in the correct version. No. Okay. So just if you want to generate it from your application, this is how the interface will look like. You just type in JHipster command, and it asks you a question, what kind of application that you want to use. For example, if you say a gateway application, just click on the gateway. And then it asks for the base name of your application. In our case, it should be store. And it asks in which port your application should run. I'm going to choose the default value, 8080 here, and the Java package name. And what kind of service discovery that you want to use. I've told you like JHipster registry, console, or no service discovery. You can choose any one in between there. And it also asks what kind of authentication that you want to have. We have OAuth 2 authentication or a JWT, which is simple. For this demo purpose, let me go with JWT. And the type of SQL database, either it's SQL or something. And then in SQL, you have these different options. For development, I can use H2, which is pretty simple. And the cache implementation, we also have Caffeine implementation or Hasselcast. Caffeine is added newly. Hasselcast is there, so you can choose whatever you want over here. Since we also have Hibernate-based backend, you can also use second-level cache using Hibernate, and to choose between Maven and Gradle. And you also have other options like adding a search engine with Elasticsearch or a WebSocket and things like that. So if you want to add any of those extra parameters over there, you can add, and we will generate an application for you. You can also go ahead and say, I don't want any client, I just want the backend. You can say that over here, but that's one option that you have. And also you can select between various versions of themes and whether you want to have multiple different languages in your application. And if you want to add in extra services like Gatling, Cucumber, Protractor for adding more tests. So whatever we generate, we also have unit testing. We use just for React and JUnit for the Java-based testing. And we have around 80+% of test coverage in the code that we are generating, which means like the entire application is pretty robust. And if you guys know about Sonar Cloud, we are one of the top projects in the Sonar Cloud ranking on the open source side. And it also installs node modules, and also it downloads the internet. I don't want to take a risk of running that in this conference server. So I have already generated an application. So as you can see here, I have already generated an application, store, notification, and an invoice-based application. So let's go ahead and check what it has. Again, it's a basic Java-based application. Hope everybody here is a Java-based developer, right? Any JavaScript developers here? Nobody? At least writes 1 or 2 lines of JavaScript? Anybody? Nobody? OK. So yeah, so this is a Java-based application which has everything added to it. It's a normal, simple Spring Boot-based application, nothing fancy inside. It's a normal Spring Boot-based, latest version of Spring Boot-based application. That's pretty much of it. It has nothing else there. And what's the most important thing is like we also understand that everybody wants to use Docker and everybody wants to go towards a cloud native side. So we generate all the Docker version of your application. So you can just go ahead, if you generate an application by default, you have this entire Docker files. So you can go ahead and run your application right from day one inside this Docker containers. And that's something you get out of it pretty easily. So since we have generated an app with MySQL database, I have a MySQL YAML file, which is again like MySQL database is specified inside. You have this monitoring. You have Sonar that is generated. So you run this Docker image. You can test the Sonar things inside your application. We also added in Grafana and Prometheus for the applications. You also have some default dashboards and data sources defined. And this goes for all the other things. For example, even in invoice, you have the same structure. And the Docker files are generated. And in notification, we have choose Mongo database. So let's see what's there. So you have this Docker. So we have this MongoDB generated Docker files there. And what's important is like we also find like in case of MongoDB, you might want to need a cluster-based database. So you also have the cluster YAML generator, which runs your MongoDB in a cluster version. Cool. That's what JHipster generates for you. We will run this application once we go to Kubernetes side. So this is your monolithic application. And when you convert that into a microservices, you have a little bit of services that are running here and there. You don't have any problems so far. You can manage with Kubernetes services. There are no problems with that so far. But when your number of services that you have or number of interactions between those services increases dramatically, for example, when you have this much amount of services, what is the problem that you will have? What will be the problem when you're dealing with this much amount of services? Sorry? Orchestrating, yes. Sorry? Troubleshooting, exactly. Any other? Logging and monitoring, perfect. Yep. So yeah, the basic thing is like it's very hard to control this many interactions or these many microservices. It's very hard to manage. It's very difficult to manage them. You might not know where the breakage is happening. And other important thing is like it's very, very difficult to secure those services because there are a lot of services that are running, and you might need a secure service, secure thing between your services to happen, and it's very difficult to maintain those everything. And in order to solve this entire thing, we have something called Istio. Istio kind of sits in there and helps you to run this application. If you want me to explain Istio in a single word, Istio is kind of a middleman that sits between your application or between your services and tries to intercept all the traffic that is going to your services. And it kind of manages, secures, controls, and maintains and connects all those services with that single middleman. That's it. That's what Istio is doing. So basically, service mesh. What's a service mesh? A mesh of services, that's it. It's a mesh of services that are network of interconnected microservices. So that's what a service mesh is all about. And what Istio does is like, without changing anything in your services, you don't need to write any specific code in your services such that it runs with Istio, because Istio is something that sits in the middle of between your services and connects with your services. So that's what is happening there. So without any change, it helps you to control, connect, secure, and observe these services. Observe is logging and monitoring. Secure and connect, you will see. And control is also like controlling how you can connect with the services and what are the things that happens to the services. That's what Istio is doing. So if you want to see in a different perspective what Istio is, so you have the service A, B, and C. You might see there are certain specific components in an application and also common components available across application. For example, logging, the monitoring aspect, or the networking through which you can connect your applications. All those things live somewhere here. So what Istio does is like plugs this common services outside and puts it a layer, and then your entire application is smaller, much smaller, and it does what it has to do. That's it. But how can Istio do this thing without affecting any of your services? So so just before we go this one, what is a pod in Kubernetes? A pod in Kubernetes. What is a pod? One or many containers, exactly. So a pod can have one or many containers, and Istio basically uses that thing, and it uses a mechanism called a sidecar, which means like it boots up a container inside a pod. So you consider this orange round or orange box as a container or as a pod, and you have your app container running inside. And what Istio does is like it expands it a bit and then adds a proxy container inside. So that's what Istio is doing. So this is done automatically. You don't need to do anything on your services. This is done at the Kubernetes level. So it adds a proxy container inside. And this proxy container is written on envoy proxy, which we will see later. But this proxy container helps you to intercept all the services that goes into the container and comes out of the container. And this is written on envoy proxy. So envoy proxy is nothing but a lightweight C++. When I mentioned lightweight C++, it means it's faster. And it's really fast, and it is also platform agnostic. The main thing that you have to note is like even though this envoy proxy is faster, there will be a little bit of latency added to your services. So you have to always mind that fact. If you have to have a very high performant application, then I think envoy proxy is not the thing that you have to go. The latency that envoy proxy is going to add is very minimal in terms of few micro to nanoseconds, but still you have to be understanding the fact this proxy sits outside your services and hears or sees all the requests that is going in and out. So this is how it looks like. This is your pod. And then you have a component called mixer inside Istio. And the mixer is responsible for controlling a policy control and also telemetry collection. So telemetry is logging and metrics collection. So the mixer is a component that sits and through which it gives information to proxy. For example, a request is coming with a parameter. The proxy is the one which decides, along with mixer, whether the request can go to the application service or you can stop it right over there. And of course, just like Kubernetes, you have something called control plane in Istio. And the control plane consists of a pilot. So pilot is the one which helps Istio components to discover these services. So pilot has information of which services runs on which IP addresses or which DNS names, and how to connect to those services. It injects that information to the mixer. So next time when a new connection comes in, the mixer is the one which decides, OK, this service runs here, so let's go ahead and connect all those things inside the proxy that is running for that application, things like that. And you have something like galley. Anybody know what's a galley? No? No? Anybody went on aeroplane before? Mm-hmm. Sorry? Yeah. It's a kitchen, the trolley that they have in which they take all those equipments, all those food, and then serve it to you. That's galley. So similar to that, it's the same concept here. Galley is the one that validates the configuration that you're giving to Istio, and it processes and distributes all those information to the underlying services. For example, it could be on a mixture level, it could be on a proxy level. And then you have Citadel, just like your town hall. It's an authentication place where it kind of does all the authentications. So together on the right side where your application is there, on an Istio it's called as data plane. And this other side is a control plane. So basically Citadel helps you to secure your services. Galley helps you to connect, share the information. Pilot helps you to control these services, while Mixture is basically for monitoring or observing your services. That's how Istio works. So let's go ahead and generate Kubernetes configuration with JHipster. We'll generate Kubernetes and Istio configuration and run it on gcloud. OK, so I've created a demo folder here. Hopefully it has nothing inside. Yes. So all I have to do is like run JHipster Kubernetes command. It asks you a bunch of questions just like before, and it will help you to generate all those things. So for example, here it asks which type of application for which you have to generate Kubernetes configuration. Let's go ahead and specify microservice application. And then it asks at which location or which directory that you have your services. So let me go ahead, and we have invoice, notification, and store. Let me select all those things. And it also asks whether you want to set up a monitoring. It gives you two options. You can choose a Prometheus, or you can use JHipster console, which has ELK and Zipkin. For now, we'll just select no here. And it also, OK, sorry, press faster. So it also says, like, OK, so in the applications that you've given, there is a cluster database. Do you want to use a cluster database? I say no here, but if you can also say yes there. And then the default namespace, I'm going to use default. And also the Docker repository, because we will be generating a Docker images and push those Docker images into the Docker repository. So it needs a Docker repository name, specifying my Docker repository. And with gcloud, you can also push Docker images into gcloud, or AWS has its own variation. So we asked like which command you would like to use for pushing your images. Well, I'm going to use Docker, so it's just a Docker push. And then it asks whether you want to enable Istio. So you can enable Istio here. So let's say yes. And once you've said like, it asks you what kind of service type that you want to use. Whether you want to use load balancer, node port, or ingress. Any Kubernetes users, can you specify the difference between these three? Oh, it's there, but still. OK. So the basic thing is like load balancer actually assigns you an external IP, while both node port and ingress doesn't give you an external IP. So if you're running something behind something, or if you want to mask your entire services running, you should basically use ingress and have an ingress controller that goes and connects to the services, while node port, on the other hand, has a different port. Let me use ingress. And then it asks to give me an ingress service. So basically, you need to have a service that runs on top of your application with which you're going to connect it. So it asks you an ingress service. Let me go to my cluster. My cluster is running over here. And let me take this IP. This is my ingress gateway IP. And I'll just add this few words, nib.io, just to generate everything. So what happened now is like it generates all those files for me, and also gives me a set of commands like tag those images and push those images to the repository, and then run this kubectl apply command to do all those things. So let me go and just check the files that are generated. So you have these four folders now: invoice, Istio, notification, and store. The store is this basic store application with all the Kubernetes configuration specified. So you have the store deployment, which has init containers. But again, like it takes a store app, store Docker container, and then runs them with the MySQL. And also it has readiness and liveness probe added to it. And you have this destination rule, in which you can specify the policy, like, for example, a load balancer with simple random. and you can specify the connection pools, like how many requests it has to time out, what are the things that you will have to do, how many times, if there is a failure, how many times you can retry, all those things are specified. Again, this entire thing that we are specifying are the industry standards. Of course, you can go ahead and modify them within the context of your application, but this is the best practices that we are following. So all those applications have a deployment, and it has a wrapping service in which your deployments is deployed. But note that this is a cluster IP, which means you cannot access those applications running on this cluster IP. In order to access it, we'll use something like virtual service. And virtual service is what Istio gives you. It creates a virtual service on top of the service that you're running. So it basically takes the store service and creates a virtual service on top of it. And the destination is a store. And it says like all the weights, like all the 100% of requests should go inside there. And it also specifies like how many retries you have to do. Similarly, you have this entire set for notification, invoice, and Istio. So inside Istio, you have this Grafana, Jaguar, and Kiali gateways, which kind of deploys those applications for your services. And with Kiali, you can observe things that is happening, check the bottlenecks in your application, while Jaguar is for tracing. It's really helpful in doing all those things. And what we're going to do is like just run this command, kubectl apply -f invoice and all those things. So it goes ahead and applies this entire folder. The one more important thing to note here Yep. So this is a basic thing that we have here. For example, in your MongoDB, you're specifying Istio sidecar as false, because we don't want any Istio properties running on top of a MongoDB and then fetching or checking on the request that is going inside. But for the other applications, we might need Istios to run. For that, what we do is like the default namespace or the namespace in which we are deploying, we say like Istio injection enable is equal to true, which means like any services that you're deploying on this particular namespace, which is default in our case, it goes ahead and adds an Istio sidecar to it. But you can specifically pinpoint your particular service and say like, don't inject anything for me over there because I know it will be handled by somebody else. So you can also have this drill down capability over there. So all I have to do is like run this kubectl apply command. So consider that I've created an image and pushed those images into the system. So that's how this entire thing will have to work. And I've just deployed everything over there. So I get this bunch of URLs with which I can check what's happening inside. So you can see this is the application that is generated, a basic application. I can sign into the application. So here, I've created a list of entities. You can also generate entities with JHipster. I guess I didn't show you that. So I have a bunch of entities here, like entity product order, entity customer. So I have this bunch of entities, which helps me to generate all those entities. So I have all those entities created. I can go and create a new thing here. And it goes ahead, saves it over here. So I can do this all sort of things. I can edit and delete all those things. So this is the basic entities that we have generated based on your application. And we also have an user management. We have metrics screen in which you can see all the metrics of your application, like the statistics of the requests that you have, the cache statistics, data source statistics, and all those things. And we can have health configuration and all those things. So, and then you have this list of applications that are running. For example, we can go ahead and check this Jaguar tracing. So you can drill down to a particular service like store a default, which is my default store. And you can see like just happened a few minutes before. So it kind of creates all those wrappers around it. So it kind of like adds in all those tracing things around it. So you just have to go and check like, you haven't specified any service registry here, Istio takes care of doing that. It creates a virtual service. With that virtual service, it helps you to connect to multiple different applications. And it also adds in all those headers that will be responsible for handling this kind of thing. So for example, you can go ahead and check, drill down and check what happened here, and what are the things that we passed in, and what are the responses that we got, and all those things will be present over here in this tracing. And you have this Kiali. So Kiali is again a service mesh observability tool. So we have these two namespaces that are running. One is the default namespace in which all our applications are there. And we have an Istio namespace on which all the Istio-related applications are present. And you can drill down to this namespace and see what are the applications that are running, MySQL, invoice, notification, and all those things. So as you can see here, all the databases doesn't have any sidecar to it. So it also specifies that it doesn't have any sidecar and things like that. So I can say like whether my application is healthy, and it also specifies like there are no inbound requests that was given to this particular application so far, and what are the workloads of this particular system, how many services are running, and what are the things that you want to do, and the invoice config. So you can also check on the graph level, so it also gives you a nice picture, like if you have any problems at any point of the services, then you might go ahead and check those things. It will have a big red mark over there. You can just go and check all those things over there. So that's what JHipster helps you to do much more faster. We created everything, and if you have a very good internet connection, I think everything will be done within 15 minutes. You can right away have this production-ready applications out of the box. So all those Kubernetes users, what are the best practices that we follow, or what are the few things that you can follow in your application that might help you to do things much more faster and concise? When you're creating a Kubernetes configuration file, I think it's better to split your YAML files and also have much smaller YAML files, because what we do over here is like we have single process responsibility principle for any YAML file that we're creating. One is a deployment, one specific for destination rule, and one specific for virtual services and things like that. When you have the smaller YAML files, it's much more easier for you to understand what is happening inside your application. And it also gives you a pretty much good history. So I think it's better to have a single responsibility. Always try to split the files, have smaller YAML files as far as you can do. And the other thing is like whatever YAML file that you're creating, keep in your mind that this needs sometimes to boot up your application. It has to download that particular version or particular tag of the Docker image, and it has to do all those things. So which means like always try to have a smaller Docker image. You can start from Alpine image and then try to add in only the components that you might need. And always try to focus on making your boot time much more faster. So anybody knows about healthy zombie problem? Heard about it before? Yes? No? Yep. What is that?
It was another session that asked, have you heard about this?
OK. Fine. So any container that you will have a single process. Any Docker container which has multiple processes inside. If one of the processes failed, then this entire Docker will not, the Docker itself will not know which process has failed, and it will report everything is fine. But for the outside world, if you go and check, it will just say like Dockers will say everything is fine. But for you, your application might fail because one of the processes is not running. So that is a healthy zombie problem. So it's like, it's actually a dead thread inside, but it says like everything is fine, I'm healthy, things like that. So always try to consider when you're creating a container, just have a single process inside. And if you have to run multiple processes inside, that's why Kubernetes went to pod, because pod can have one or more containers inside, which means like you can add all those things there. So it's better to think in that way. Always have a single process in your container. If you want to add in more containers, and if you're using Kubernetes, use multiple containers. And the other thing is like services have this red pattern of testing, which is like request, errors, and duration. Always check those 3 metrics, which helps you to understand how your application behaves and what are the impacts that you have to do. For resources, try to use pattern, which is like number utilization, saturation, and errors. This is a use pattern. Like keep on monitoring the utilization, the saturation of your services, and also, or the resources, and also the errors in your resources. Think about request and limits. Always consider, like when you're creating an YAML file, think how much request limits that you're going to give to the container, how much memory or how much RAM that you're going to give to your container. Clean up unused resource is a classical one, and always monitor and tune your services based on the needs. So that's it from the presentation. Any questions? No? No questions? Everybody all clear? OK, thank you very much.